Hey everyone, welcome back to another video by Camroom 5. In today's video, we're going to be talking about the second type of catalyst, which were the heterogeneous catalysts. The name implies that they are in a different phase compared to the reactants, because hetero means different and they are in a different phase, right? So let's write this thing about them. They are in a different phase as the reactants. We have had good examples of how heterogeneous catalysts appear in our syllabus. We will be talking about this important phenomena called adsorption. It starts with letter A and then D for doctor. Adsorption basically is the main phenomena, and it means making weak bonds with the surface particles. So here, adsorption is all about making bonds with the particles on surface of a solid. It's really important to make sure that it's different from absorption, and it starts with letter A and then D. What kind of solid we use is mostly a transition element. So you make weak bonds with surface particles of a solid, which is mostly a transition element. What is so special about transition elements, and why do they behave like this? So they have got valence d orbitals that are energetically accessible. I should have called it vacant d orbitals, which are energetically accessible. So these orbitals are energetically accessible, which means that they have this vacancy where partial bonds can be made. By the way, this statement comes from this syllabus, and I would really appreciate if you could kind of, more or less memorize this statement. So let's dig deeper into the adsorption concept. Stage 1 that happens is called diffusion. Now, how it happens is very obvious that, for example, I'm using iron as a catalyst for the Haber process. So I have got a plate of iron. This is not how it's arranged actually in the Haber process, but hydrogen and nitrogen gases will diffuse closer to the catalyst plate, which is a solid surface. This is basic diffusion. So gases diffuse closer to towards the catalyst. Nothing big about it. Once this process has been done, now I have tried to magnify on the atoms of the surface so I can go for the process of adsorption. During adsorption, your reactant molecules will start making weak bonds with the particles on the surface. These particles on the surface will have vacant d orbitals. And these weak bonds are made with the particles on the surface with the d orbitals, but I'm not going to show the d orbitals. These atoms had vacant d orbitals, so I'm writing this again. I really want you to memorize this statement. That is why I am, talking about it again and again. The whole idea of being energetically accessible is also important for me. Now, important thing about these weak bonds is that when, let's suppose, nitrogen atoms for Haber process and let's suppose the hydrogen atoms for the Haber process make these bonds were strong enough that the reactant bonds themselves break down. So these bonds that are made with the atoms of the surface or the particles of the surface, these bonds were strong enough that the reactant molecules break their bonds. So strong enough to break covalent bonds between the reactants. So hydrogen itself breaks these bonds, and nitrogen like molecule breaks their own bonds. Another thing important about these bonds made with the surface particle is that they are weak enough that it breaks down once the product is formed. So these are not permanent bonds. These bonds with the particle surface will break down once the product itself is made. And that phenomena is called chemisorption, or you can just call it chemi-absorbed ho gaye. Moving on. Stage 3 happens when the reaction actually begins. So once the weak bonds have been made with the particles of the surface, the reactant molecules can now react with each other on the surface, and this reaction will happen at whatever speed, but the surface particles provide enough space for this reaction to happen. So these atoms react on surface to make products. Once the products have been made, then stage 4 happens, which is called desorption. During desorption, the ammonia molecules that have been made recently, they were still bonded with the particles of the surface through those weak bonds. And now once the product has been made, these weak bonds should be broken down. So gradually you will see these weak bonds becoming more and more weaker. You can see these blue lines are becoming more and more dotted, which means that the intensity of weak bonds is becoming even more weaker. So bonds with surface particles become more weaker. So they weaken more, and now they will just break down. Once these bonds break down, ammonia molecules are not bonded to the surface particles anymore, and then stage 5 happens, which is called diffusion again. The ammonia molecules that have recently been formed will diffuse away from the catalyst solid surface. So they diffuse away, that's basic. Let's recall all these stages so that we have a clear understanding of what happened and why it happened. Number 1, diffusion happens towards the solid surface, towards the surface of the catalyst. Stage 2, adsorption happens. What was adsorption? Adsorption was basically making weak bonds with surface particles. Then stage 3 happens, where actually the reaction will go on. So during reaction, what happens is that atoms kind of react on solid surface. They break their initial original bonds and make new bonds. In stage 4, desorption happens, which means bond with solid surface particles will weaken. So the bonds with solid surface particles that was made initially in the adsorption phase will now weaken. And in stage 5, diffusion happens again. So in diffusion, the product molecules will diffuse away from the catalyst surface. I hope this idea is clear to you guys. Stay tuned.